Okay, I can describe this locus here geometrically straight away. This actually says z minus, and it's 4 plus 0i. And this says z minus, and it's 0 plus 2i. So you have your minus your 0 plus 2i, which is there on the imaginary axis. And you've got your 4 plus 0i, which is there on your real axis. That's the point 4, 0. And anything that is the same distance from each of those is going to be on the perpendicular bisector of that. So wherever that is, it's going to lie on that line that runs perpendicular to the joining interval there from those 2 points. So it lies on the perpendicular bisector of 0, 2, and 4, 0, or 4 plus 0i and 0 plus 2i. So that's geometrically what's going to happen. And that makes sense because you take any point on there, like that point, and it's equidistant from each point. Okay, so that's describing it geometrically. It's Z is on the perpendicular bisector. I'll write it down. Z is on the perpendicular bisector because it cuts, see, it cuts that interval in half, of 4 plus 0i and 0 minus 2i, if you like. So 0 plus 2i, yeah, because it says minus 4 and minus 2i, that's right. So that's the situation we've got. Now let's work out the answer. So the easiest way, I think, is to let z equal x plus iy, some roaming point x plus iy. So we've got x plus iy minus 4 up there, and equals x plus iy minus 2i. That's what it says, yeah. So we've got to work that through. So we know that this actually says x minus 4 plus iy equals x plus y minus 2i. And then the mod is just the square root of x minus 4 squared plus y squared here, and the square root of x squared plus y minus 2 squared. Square both sides and we get x minus 4 squared plus y squared equals x squared plus y minus 2 squared. Well, it's getting a bit there we go, fix that one up there. Let's get all the x's across here. So we've got x minus 4 squared minus x squared equals y minus 2 squared minus y squared. Well, I can then go, that will be a squared minus b squared. So a minus b times a plus b equals a minus b times a plus b, because a squared minus b squared on both sides. So x minus x, that's minus 4 brackets, x plus x, that's 2x minus 4 there. And this is y minus y, so minus 2 and y plus y, 2y minus 2. Okay, so if I divide both sides by minus 2, I get 2x minus 4 equals 2y minus 2. So that's 4. Actually, divide that by 2 as well. Divide both sides by 2 again would work. And get 2x minus 4 equals y minus 1. So in general form, this is 2x minus y minus 4 plus 1 minus 3 equals 0. Or we might get y equals 2x minus 3. Now I'm just going to check up if that's in any way reasonable. The gradient, yeah, it's positive. Probably goes through minus 3. My picture's certainly not to scale. Y equals 2x minus 3 sounds reasonable. Now, the 2 points themselves should lie not on that interval, but the midpoint of those 2 points should lie on that equation. That's for sure. And what's the midpoint of those 2 points that are given there? The midpoint is 2, 1, if I just average out the points. So 2, 1 should lie on there if I want to check that. Does 1 equal 2 times 2 minus 3? Yes, it does. So that appears to be, in general form, or in gradient intercept form, that appears to be the equation of the locus, and which I've already described as basically the perpendicular bisector of 4 plus 0i and 0 plus 2i, or the points 2 and 4 on those axes.